all the documents will be couriered to your address, the physical copy, I mean hard copy, and the soft copies also you can download from this link whenever you get registered, and you registered for the physical design course only, you can access this, and 24/7 you can access that data also. And if you have any further information needed, you can contact our HR, or you can contact to this number also. And if you need to mail, you can use this mail to have communication, the further communication. So yeah, let's move to the next slide. So eligibility, which people are eligible for this VLSA industry? I mean, who can enter into this VLS industry in a basic manner? So if you are a person comes from a ECE stream, ECE or EEE or CSE also, you can enter into this VLSA field if you are pursuing or completed BTech or MTech, right? So yeah, so how the salary structure would be there in VLS industry for basic, for a fresher, how it would be, and for each stage of experience, how much you are going to get. I mean, this is not like a fixed pay. The pay maybe varies, but I mean, based on the skills you have, based on the experience you have. Okay, so as a fresher, you may get 4 to 6 lakhs as a fresher. Okay, so with 3 years of experience, you are going to get 12 to 15 lakhs of package, and if you become a lead with 5+ years of experience, you can get 25 to 30 lakhs. Okay, so if you become a manager, you can't imagine the things. Okay, so that is the beauty of VLS industry. And in this VLS industry, physical design is like very challenging, and how to say, very challenging, and it will gives you motivation, it gives you boost every day you will see new thing, every day you can learn new things. Okay, so that's what I can say from regarding physical design actually. Okay, among all the streams, physical design is like very active thing, and you can learn everything, anything on every day. Okay, so if we move to the next slide, yeah, placement support, as I said, actually we have 200 plus companies which are hiring for the physical design engineers. So in that, these L&T, Capgemini, HCL, Wipro, all these are like service based companies, and AMD and Synopsys. This is here Synopsys was written, right? This is a service based company. AMD, Microchip, Intel, Qualcomm, Nvidia, all these are product based companies. Among all these companies, we can have placement. If they release a placement, I mean, if they are trying to hire, then you will be we are going to give placement assistance till you get placed. Okay, after completion of this course, and after giving a completion of this training, you won't be leave alone. I mean, we won't leave you alone. We will try to place you in any one of the company. Okay, till you get placed. Okay, we'll give our 100% efforts to get you placed. Okay, so as I said, tool and interview support till get placement. Okay, we're going to conduct mock interviews, and we're going to give tool. Okay, what really this tool is, and how it works, where we need all this tool and all, you're going to see in the next slides. And in the technical sessions, you're going to operate the tool with your own hands, so that you can get the practical knowledge also, so that you can become a pro from a scratch. You're going to be a pro after by the time you complete this technical sessions. Okay, so just need your hard work and a basic understanding of what really this physical design and what we are really trying to do. Then you can really achieve many things, and you can go for unbelievable heights. Okay, that is the beauty of this VLSA industry actually. And in that, physical design have more scope for that. Okay, so these are the companies, as I said, Synapse Design, Sientra, Cerium, all these are like service-based companies. Synopsys and Western Digital, some of the things are like Moss-Chip, all these are like product-based companies. And so all these companies, so we can give assistance till you get placed. We won't leave you after completion of this training and all. We will give you assistance, including mock interviews and personality development. Okay, and we are going to give you the how to answer a real tough questions, how the environment would be, everything we are going to teach you. Okay, don't worry, you are in safe hands, and we are going to teach you and tell you, and we are going to train you in every manner. Yeah, So if we come to the curriculum, what we are going to teach you, what are things you're going to learn? Here is the curriculum. So basics of Linux and CMOS, digital electronics, physical design, Verilog, DFT, synthesis. I mean, these technical words makes you get confused, but I'm going to explain all these technical terms and the real meaning and the real operation you're going to learn in the practical knowledge along with tool in the technical sessions only. Okay. So 1 second. Yeah. So basics of Linux. So what really Linux is like, we have many OS platforms like Windows and iOS, we have OS, right? So Mac OS, like that, Linux also one of the kind of OS, okay? So here we can make the things very easy, okay? When compared to this Windows and Mac OS, all these things, we can perform the things in this Linux terminal, in this Linux OS, we can make these things very easily and effectively. Okay. For example, to copy a particular thing in this Linux, just use CP and the source file and the destination where you need to copy. That's it. You can copy the thing. If you want to move from one place to another place, just give the command like mv move from source and destination, this place, like this. Very simple and very accurate commands which can make our work very easy and accurate and effectively. Okay. So this is what we are going entire real estate industry going to already working on Linux OS only. So we are going to give the basics of Linux, what it really looks like and how we need to work, what are the basic commands we need to perform to enter into this real estate industry. What are the real knowledge in terms of Linux we are going to teach you. This is the scratch. From here, we are going to start training you people, and by the end of this training session, trust me, you're going to be a pro. I'm telling you again and again, and I'm going to tell you the best part, what we are offering you people related to this PD course. I'm going to tell you in the further slides also, which our competitors are not providing, but we are only providing through upgrade VLSI technologies. I'm going to tell you in the next slides. Okay. So the CMOS basics as a module 2. So what really CMOS is and how it works, and by using this, how VLSI industry is working on all these things, you'll be you'll learn in the training sessions only. So this is like curriculum. So we are going to teach you. Okay. So basics of CMOS, and in the next module, digital electronics. In the bachelor's or master's, you may be aware of all these digital electronics, but again, we want to revise the things and rebrush the basic concepts. And we're going to teach you what are the real things, what are the real digital electronic things you need to learn, you need to remember. We're going to teach you so that you can enter into this VLS industry with confidence, okay, with boost levels. Okay. So we are going to rebrush and teach you all these things from scratch. Okay. So here the main thing is like physical design. So what really physical design is like, some partitioning, floor planning, placement, all these are like technical terms. What really happens in these things, I'm going to explain in the next slides. So this is where physical design enters. Actually, this is like a complete process to make a chip. First, you need to have some, if you have an idea, you need to have some specification of that particular idea. Then we are going to convert into architectural design, then functional design and logical design. Then we are going to create circuits. After creating circuits, we are going to we are going to enter into this physical design. Okay, what really the steps inside this physical design and what really happens in all those steps, I'm going to explain in the next slides. Okay. Yeah, please listen carefully, and if you have any doubts, please unmute your mic and please ask me. Okay. Yeah. So yeah, as I said earlier, what we are really giving you, which other institutes are not going to provide, is like, this is one of the example, which is like Verilog syntax. What really Verilog and how Verilog works and how Verilog is useful for a physical design engineer, we are going to teach you. Okay. So for a physical design course, usually from taking the inputs for physical design, everybody starts from taking inputs and giving the proper outputs. This is how usually anybody teaches the physical design course, but we are going to tell you how The inputs are being generated for physical design. From there we are going to start. Okay, we won't tell you the thing like, okay, physical design, all these are the steps inside this physical design. We are not going to teach you like this. Okay, from here, what really happens here, how the output is being generated and enter into this stage, and how the output is enter into this stage. That's how we are going to teach you. uh, to show you the example, this is how Verilog syntax. From Verilog, we are going to start. I mean, we are not going to tell you like a complete Verilog course will be included, but we're going to tell you a basic flavor of Verilog, how a Verilog looks like, how a Verilog behaves, and how a Verilog is the input for a physical design. We're going to teach you all these things in the technical sessions. Okay, so let's move to the next stage. Yeah, DFT. And this is the second thing which we are only giving through this upgrade VLS technology, and you will nowhere you can see this thing in any of the other institutes. Actually, DFT, what really DFT is and how really DFT works, how really DFT useful for physical design, we are going to teach you. Okay, this is a new course, new stream inside this VLSA technology, but we are going to teach you the basic flavor, what really DFT, how we are going to use, and how it is useful for physical design. We are going to teach this also. And this is the second advantage joining in this upgrade VLSA technologies. Okay, that's a proud moment. Actually, we are going to teach you, we are going to show you all these things, including physical design. That's what I'm trying to tell. Yeah, next, move to the next slide. Synthesis. Yeah, this is the basic stage of physical design. What really synthesis is, I'm going to tell you through this slide. So synthesis is like, first, if you have an idea to be converted into a chip, first the basic thing is like RTL code to be generated. So RTL code, from RTL code to, it is only just a code, but we need to implement with the real circuits. Okay, so from RTL code to the gate levels. Gate means NAND, NOR, all these gates we have, right? So in the RTL code, we are going to use the real gates and apply the inputs as per our idea. So we are going to test what really the output is coming and are we going in the right track or not. So in the basic flavor, conversion of RTL code into the gate level netlist is called synthesis. Okay, synthesis means RTL level RTL code into gate level netlist, which is the input of physical design. The process of conversion is called synthesis. Okay, so yeah, and nobody teaches you what really synthesis is and what really happens inside synthesis, and we are going to teach you. That's what I tried to tell you. So we are going to teach you very crucial things which are really required. Okay, we are not going to start physical design, what really physical design is. Okay, we are going to start how physical design is evolved with the earlier stages. Okay, we are going to touch all these stages, then we will enter into the physical design. What really happens inside the physical design, we are going to touch at that part, and that at that time you are going to use the real-time tools like as I said, IC compiler and prime time. Then you are going to get a best experience, best real-time experience. To get the best idea, a clear idea how our industry is working, how we are going to work, how our life is going to be inside this VLS industry as a physical design engineer. We are going to teach you all these things. Okay, so that's why we are trying to teach all these Verilog syntaxes and DFT synthesis. That's why we started from the Verilog. Okay, we are going to teach everything before entering to this physical design. Actually, yeah. So inside the synthesis, what are the real steps included in synthesis is like this optimization, unify, wire load model. Okay, all these things will be like very technical, and you'll get confused. So I don't want to discuss all these things, but what really these are like a conditions. Within this time, we need to close our chip activity. Within this area, we need to close our chip activity. All these things. So what really those things are and how really those things works, you can learn and see all these things in technical sessions only. Okay, and we are going to cover all these things. These will be included in inside of synthesis only. Okay, we won't tell you like synthesis is like just a conversion of RTL to netlist. we are going to teach you what really happens inside synthesis also. That's the beauty from upgrade VLSI technologies. Okay, so STA is like static timing analysis. Okay, so static timing analysis means as a physical design engineers, we have three goals. We should get our chip, okay, to being worked within particular limit of time, within minimum area, and less power is getting waste. Okay, all these targets we need to satisfy every time for every chip in every perspective. Okay, so in the first challenge is like timing. So that's what, to measure and to calculate the timing, to check the violations in terms of timing, we use the process is like static timing analysis we use. Okay, so as I shown you, right, one prime time tool from Synopsys. Prime time tool is being used to do all these STA related things to be performed. Okay, so what really STA is, how we use STA, and how it works, how it helps for a physical design engineer, I'm going to teach you through the next slides. And the real scenarios you can only learn in the technical sessions only. Okay, so see, this is the RTL code and this is the gate level netlist. This process is called conversion from here to here is called synthesis. Okay, so before entering to this synthesis also, we are going to use STA. Okay, so after a completion of this netlist, again we need to check the timing, means STA, static timing analysis. Okay, so before starting, PNR means place and route. In a simple, in a shortcut we can tell, or PD, physical design we can say. Okay, before starting these PD activities also, we need to perform the timing analysis. Why we are doing multiple times means, as I said, right, we have only three targets. Minimum time, within less time only you need to achieve some proper things which needs to be performed, and within minimum area only you need to perform all these activities, and less power to be wasted. Anyway, power is getting wasted. Okay, but within less power wastage, we need to perform all these activities. So as the first challenge, we need to perform all these STA checks in most of the stages, so that we can assure like, okay, we're going in a good way and we're going to get the best results. So to get this assurance, we need to check all these timing activities in multiple stages. Okay, so after entering to this PNR, we will get one stage like clock tree synthesis. Okay, CTS. There the real clock enters. After entering to this CTS also, we will perform one STA, which is like static timing analysis activity. Again, we will check the timing to confirm whether we are in good shape in terms of timing or not. And after that, we will route the thing. I mean, what really route is, I'm going to explain in the next slides. Okay, so after routing also, we perform the STA activity, and this would be the final stage. If we clean with this stage, done, we are going to get the chip manufactured. Okay, so yeah, in the next slide, yeah, physical design flow. So what really physical design flow, and what are the steps included, and how it works, and what are the things, what are the checks to be performed, what are the inputs for each stage, I'm going to explain in the next slides. Okay, so yeah, this is the first stage of physical design. Okay, which is like import design. Okay, so what are the inputs for physical design, what really we need to have to start a PD activity. Okay, so gate level netlist, which we converted RTL code into gate level netlist through synthesis. Yeah, the output of synthesis we need to use as a primary input. Okay, so constraints, which is like as I said, right, within this time we need to close the chip. I mean, we need to close the timing activity. Within this area, we need to perform all these activities. Within this power wastage only, we need to perform all these activities. These are the guidelines which we get. Sorry, in a simple manner, we call it like constraints. Okay, logical and physical libraries. So these are like technical terms, and you are going to learn what really logical and physical library in the technical sessions. All these are like inputs I'm trying to tell, def and scanf, UPF. These are like very much technical. When you enter, when you use that tool, you're going to learn all these things, how it looks like, what really it consists of. I'm going to teach you in the technical session. Okay, these are the basic inputs for physical design. Okay, so yeah, input design and initial checks inside the lab. Whenever you try to use the tool, right, This is the basic step. Okay, so this is how it looks like at the import design stage. Okay, so all these purple color are standard cells, and these blocks are there, right? All these are like macros. So the first step in physical design is like place all these macro, I mean these boxes are being called like macros. Okay, to place all these macros all over this chip, and get all these cells placed inside this core area. This empty space is called core area. Okay, so place all these macros and get all these cells placed inside this core only. So that's how our physical design activity work starts. Okay, so floor planning and power planning. Floor planning is like the process of this arranging these macros. These are called macros. Actually, before starting the PD activity, all these macros will be placed at 0 0, means x coordinate is 0 and y coordinate 0, means here we need to arrange all these macros as per their communication with standard cells, as per their communication with these IO pads. You see a straps here, right? These are like pads. Okay, in the next slide I will try to show. Yeah, these are the like IO pads. These are like power, ground, and some signal pads would be there. So with respect to these pads, the communication between these macros and these pads, based on this communication, we are going to place all these macros. Okay, so this is how after placing all these macros, this is how our design looks like. Okay, this is the first step, which is like floor planning. Completion of floor planning is like this. Okay, so based on the communication between these IOs and these macros, we try to arrange all these macros. This is called a floor plan, and this is like a basic step in the floor in the physical design. Okay, so and power planning is like all these pads are there, right? So like this only we're going, actually that flow itself will be build the grid. Okay, we're going to build a power grid like this horizontally and vertically, so that we can arrange all the, I mean we can arrange power to every cell. So if a cell is getting enough power, it will work properly. Okay, so this is the completion of floor plan, and these are the standard cells still sitting outside. Okay, all these standard cells will be sitting inside this core area. Here empty space is there, right? Left out. This is called core area, as I said. Okay, in the next stage, all the standard cell will enter and sitting here. Okay, so based on the communication between these standard cells with macros, and the communication between these IO pads, all these four sets we have the border, right? Some straps. These are like IO pads. Communication between these macros and IO, and macros to standard cell, and each macro to macro communication defines the thing where the macro should be placed. Anybody asking something? Fine. Yeah, this is how completion of floor plan looks like. This is how a perfect floor plan looks like. Okay, so let's move to the next stage, which is like placement. Okay, so placement is the stage which we call like as I said, right? These are the standard cells. In this placement stage, all the standard cells will be sitting here. Okay, so that stage is called placement. Okay, in this also we have multiple steps, what really placement is, and how placement is going to be worked, and what are the stages in placement. You can see all these things in the technical sessions, and you can perform all these things with your own hands by using the Synopsys ICC compiler. Okay, and prime time tools. Okay, so the basic placement goals is like less utilization. Less utilization means sorry, so using less area to make all these cells sitting inside this core area. Make sure to use less area, so that our target is like less, I mean within less time only we need to perform all the activities. For that we are performing every stage the STA activity, static timing analysis activity. Okay, so in the next constraint is like place. So within less area only we're going to sit all these we are going to make placing all these cells inside this core area. That is our second target. Okay, so that is called like utilization. Yeah, less utilization means less area. So no congestion, no overlaps, good timing values. All these are like very technical terms. I'm going to explain the next slides, and you're going to learn what really those are being called in the technical sessions. Okay, so yeah, after placement, this is how it looks like. Okay, all the stand cells are sitting inside this core, right? So this is how, for sitting all these to make sit all these cells, right, we need to use less area as much as possible. Okay, I mean, as less as possible area. This is like our second target, as I said. Okay, this is how after placement looks like, a design looks like. Okay, so the next stage is like CTS. CTS is the stage where real clock enters into the picture actually. So in the first stage, we are arranging all these macros. In the second stage, we are placing all these cells. Now we need to provide clock to each cell. I mean, which are really required the clock. We're going to activate the clock so that if one cell is being performed related to the clock, so the next cell would be activated in the meanwhile. So that is how CTS works for actually. What really happens inside the CTS, I'm going to tell you in the next slide. Okay, so yeah, so see, if we are giving clock here, okay, so just imagine this is a flop. So if you give a clock to this flop, then it activates this flop in the next clock period. So by this time, the see, I will try to tell in the simple words. So first, if you use this flop, okay, so if the clock enters for this flop, then within meanwhile, clock needs to go reach this flop and should activate this. Then the operation occurs and the output comes as the input for the second flop. Meanwhile, the clock should reach here. Okay, so that, I mean, the data and the clock should be reached at the same time so that it will get activated, and it will meanwhile while reaching this clock and it is getting activated of this flop, the third flop should being activated by arrival of the clock. Okay, so in a simple words, okay, the how to tell in a simple words, yeah, balancing a clock tree. Okay, so if we connect all these flops with a clock, okay, clock net, so balancing means within a particular time which we get as a constraint, the clock should reach this flop. Okay, within particular time which we got as a constraint, the clock starts from here and activate this. That's how we need to balance. Means we need to delay or we need to make it faster as per our convenience. Okay, so we need to perform all these things inside CTS. What really CTS is, how, why clock, what is the use of clock, everything you're going to learn in technical sessions. Okay, all these things will be covered in inside these technical sessions. Okay, no need to worry of any of this technical word. Actually, everything will be you will be learning all these things, and you will be like getting confidence to enter into this VLSI industry. Okay, so no need to worry about any of these things. Everything will be taught to you people. Okay, so in the next slide, yeah, actually we have different types of clock trees, as I said, right? See, from here clock is going to this flop and this flop, this flop, kind of. So this whole structure, we call it in a simple manner a clock tree. Okay, so these are the types of clock trees. Okay, so this is like clock tree and clock mesh and clock spines also. This is like very old method, but based on the project, based on the requirement, we can use this also. But this clock mesh we are going to use, we are actually using in the current times also. Okay, what really happens in this and why we are not using this, when we can use this, all these things you can see really with your own hands in the technical sessions, when you are sitting in a lab, and when we teach all these things, you can understand all these things. Okay, in the technical sessions you are going to learn all these things. Okay, actually we are only going to teach what really this is and why we are not using this. If we really need to use this method, when at in which situation we are going to use this thing, why not this, everything we are going to teach you. Okay, that is the best part from upgrade VLSI technology. From scratch to a pro, we can teach you, we can tell you everything. Okay, so usually, as I said, static timing analysis, right? But we have another method to calculate timing also, which is like dynamic timing analysis. But why we are not using dynamic timing analysis? Nobody gonna teach you, but in upgrade VLSI technology, we are going to teach you why we are not using dynamic, why we are going for only static. We're going to teach you in the technical sessions only. Okay, for all these interesting things and to learn from scratch to become a pro, you need to get registered your seat inside this upgrade VLSI technologies. That's what I'm trying to tell you. You are going to learn more and more things when you compare to the neighbors. Okay, I mean our competitors. That is the beauty part from our upgrade VLSI technology. I can tell you proudly. Yeah. So after CTS, yeah, defining routing rule, define target insertion. Oh, all these will be like very technical. Yeah. Oh, and the targets, as I said, right, within this time only we need to achieve our operations and all those things. So all these things you can see inside the lab when you are doing with your own hands and you're experiencing the real-time operation, then you can understand all these things. And you are going to do all this, defining routing rule, what really routing rule is and what really target insertion delay, all these things you're going to be performed by yourself only. And because we are going to teach you what really it is, okay, with your own hands you're going to explore, then only you can get a good knowledge. We are here to help you to achieve everything, okay, inside this every stage. Okay, so this is what you are going to do regarding to CTS inside the lab. Okay, so routing, yeah, what really routing is, as I said, routing is like routing is like we have yeah, for example, I will try to tell in a simple words. We have a power socket and we have a bulb. Okay, but the communication between these two is like a wire, right? So route is technically being called as, I mean, wire is being technically called as like route, means from the power source to the standard cell, the connection between the connection supplier is like route. Okay, a metal route. Okay, so what really route and why routing, how routing gets performed, all these things in the technical session you are going to do yourself, because we are going to teach you what it really is. We are going to show you for several times till you understand all these concepts. Then we will allow you to experience in the real time by yourself only. Then only you will get good knowledge. All these things will be get done by using the Synopsys IC compiler. That is the tool which can show you everything. Okay, we're going to give like a brief explanation in the technical sessions, how to route, what route is, and how really route works. All those things we're going to explain for several times till you understand the concept. Then you can experience yourself only. Okay, we're going to teach you and we are here to mentor you. We're going to train you, okay, till you understand the concept, till you can perform. Okay, yeah, usually as I see in some of the institutes, just they will tell you theoretically and they will allow you inside the lab and they will tell you like, okay, perform routing and show me. We are not going to tell you like that. Okay, we are going to assist you in each aspect. Okay, we're going to tell you everything. We're going to show you several times till you understand the concept. Then you can experience in the real time also. Then you will never forget that concept in your lifetime. That's what we're trying to perform, and that's how we are trying to train you people actually. Okay, so yeah, after this routing, you can't see the how routing really looks like, but inside this lab you're going to see how routing looks like really. So what is this, like number of out of boundary ports, min grid error. Okay, these are like fully technical and not needed as of now. In the technical sessions you are going to learn all these things. After routing, how design looks like. Before routing, how design looks like. While routing, how design looks like. Everything you can experience, okay, inside the lab, and we're going to show you several times. Then you can feel it, you can experience it in real time by yourself also. Okay, yeah. So after physical design, what are the checks? Yeah, here again the good part is, the thing is like nobody will teach you, I mean all these checks. Okay, everybody can teach you till this routing. With this routing we can conclude the physical design activity, but we are going to teach you the output of physical design activity also. Means what are the sanity checks we need to perform after the physical design, and how it really looks like and what it is, and how to conclude if you have error, how to deal with it. We are going to teach you these things also. And that's what I'm trying to tell you proudly. Nowhere you will get this information like industrial experience, but we are going to teach you these things also, including physical design. Okay, including physical design, we're going to teach you Verilog basic flavor, how it looks like and how it gives the output, how it becomes the input for physical design. And DFT is like design for testability. Okay, so DFT and STA and physical verification, all these checks we're going to teach you, and all these are being included with physical design course. That is the beauty part. From Upgrade VLSI Technologies only we can tell you proudly this thing. Okay, yeah. What really formality is, what really LVS is, everything which are like, these are like sanity checks, we can say. Sanity checks means we performed all our activities. Okay, so what are the things to guide, to decide we are in a good track or we are doing some mistake. These are the sanity checks to define all those things. As I said, timing analysis, right? This is like static timing analysis, DRV. Okay, those will be technical, too much for you. So IR drop analysis, yeah, this is one of the best part. Nobody is going to teach you IR drop analysis, but we are going to teach you IR drop analysis also. Actually, this is a separate stream. This physical verification is separate stream, but only in Upgrade VLSI Technology we are include all these things along with physical design. Okay, that's what we are committed for. From a scratch to a pro, that's what we're going to make you people. Okay, so this IR drop analysis is like separate stream in VLS industry, but we are going to show you what IR drop, how IR drop, and why IR drop, how to reduce this IR drop. Everything we are going to teach you people. Okay, that is the beauty part. Yeah, to get all these things, to learn all these things, please register your seat and join Upgrade VLSI Technologies as soon as possible, because we are starting the new batch very soon, and we have multiple openings nowadays. Okay, inside this industry. So if you lose even one day, you are getting away from the job within a 1 day time. Okay, so as soon as possible, join in this institute, get your course done and get your job, and get all these things, get all this information on your fingertips, and become a pro and enter into this VLSA industry. That's what I can tell you. Okay, yeah, that's what from my side. And if you have any queries or issues, any doubts, you can unmute your mic, please raise and shoot. Anybody, anything related to PD, anything related to VLSA, I'll try to answer. Okay, anybody?
Hello.
Yeah.
Yeah. Hi, sir. Myself, Kiran.
Yeah, Kiran, tell me, Kiran.
Yeah. Actually, I have doubts. Like in physical design, we need to code in this RTL part.
You're asking like, do we need to code? Do we
Yeah.
need
Yeah.
coding? No, no, no,
Yeah.
no, no, no. Yeah, here I'm trying to tell you, RTL is separate stream, Kiran. After RTL, design verification team will enter into the picture. They use this Verilog code, Verilog syntax. Okay, they will
Okay.
provide their output as our input. Okay, so no need of coding actually inside this physical design. No need of coding, but the thing is like, you can learn Tcl and Perl. Two coding languages are there which are not really necessary, but the thing is like, you can use these things to get your things done in a fast manner. It's your own interest, own efforts, all these things, but no need of coding inside this physical design. I can tell you that. Okay, RTL is complete different stream, Kiran. You no need to do any RTL coding. Okay. Yeah.
Like what I came to know that it's like perfectly tool based thing we have to move on.
Yeah, physical design. Yes, true. I mean, but as I said, I am not telling you like no code will be there. Okay. I mean, you don't need to code to get your things done in a faster way. When you when compared to the others, your colleagues, if you need to perform a single task in a faster way, you need coding. It's your
Yeah.
own interest. Understood the thing, right?
Yeah. Came to
Yeah,
know.
that's what I'm trying to tell. Yeah, thanks for asking, man. At least
Yeah.
raise your voice, ask your doubts. Even it is a silly thing related to PD, I'm here to help you. Okay, whatever. Okay, please. Thanks, Kiran. Thanks for initiating.
Thank you, sir. It's
Yeah,
my pleasure.
yeah. Anybody else? Please raise your voice. Any silly question regarding this PD, I'm here to answer. Anybody?
Hi, Jeevan. This is Sharanya.
Yeah, hi Sharanya. Tell me.
We need the VLSI basics, right? Like digital electronics, all the NAND and everything.
Uh-huh.
How much we can use in the PD?
You won't really use this NAND gate, all these things you won't really use with your hands, okay? But these are the basics, okay? By
Yeah.
giving which input you're going to operate. I mean, if you need one as output, okay? Okay.
Yeah.
If you need one as output, what are the gates we can use? The basic idea you need to have. That's what. All these digital electronics, basics of CMOS will be used to enter, to crack the job only. After entering into this VLS industry, your race will starts like close the design within timing limit, within minimum area, within less power wastage. Okay. You won't be using, oh, this is like my NAND gate. Where can I use it? The situation will never occur to you. Very, very worst case. Okay. Everything will be taken care in this RTL and design verification team only. Okay. Inside the tool, how much you know, how much you can perform is your caliber. Understood the thing, right?
Yeah.
Yeah. Thanks, man. Thanks for asking. Yeah.
For the basics, it will like how much time it will take?
How much time it will take means?
So for the digital electronics, like we will understand what is the mechanism of the gates, right?
Yeah.
So after that, when we are going with the tool, so how much time we can take it for learning?
No. I think you got confused. Good name, please. Shivani? Sharanya, sorry. Yeah, Sharanya, that's what I'm trying to tell you. Digital electronics, all this CMOS, you are nowhere you are going to see inside this tool. Okay, these are like the operation.
That is the basics, the one we have to
understand. Yeah, the operation you need to know. Okay, based on the operation, you need to perform the actions inside this tool. But nowhere you are going to see, oh, this is the NAND gate. Oh, it have two inputs. Nowhere you are going to see all these things. That's RTL and DV people headache. Okay. Yeah. Only your concern, as I said, close all these activities within less timing. As less timing you have, that much best chip you have. For example, you have your mobile phone. Okay, it have fingerprint sensor. Okay. Yeah. When the touch mobile introduced with fingerprint sensor, it may just imagine it was taking like 1 second. When you put your finger on the fingerprint sensor, it was taking like 1 second. It was like, for example, I'm trying to tell you, okay, don't take it seriously. Okay, so that was like kind of 180 nanometer technology. Okay, very less area, very much time it is taking to operate. Okay, when you come to this 10 nanometer technology, within 10th part of 1 second, okay, or 100th part of a second, it should wake the screen up. That's how we are going to evolve. Okay, that's so the less time it takes, the best chip you makes. You got the thing right? Yeah. Thanks for asking. Then anything else?
No, thank you.
Yeah, anybody else? Please raise your voice. This is the chance. Actually, this is the chance you will get to ask whatever the question related to PD. Please, okay, whatever the doubt you have, even it is a silly thing, please ask. It's okay.
Hello.
Yeah.
Hi, sir. Sorry to come again.
Yeah, please.
Yeah, like what you're saying, like I was Googled before the I was searching on the like in physical domain itself, like we have what you said that static timing analysis and tree clock synthesis. It's all like floor planning. It will be like in physical domain only. There are some multiple domain, no, like a floor planning, routing, static timing analysis. Like will be part of that, or like will be going through that only. Or
Actually, to be honest, I didn't get the question properly. Can you please repeat and just use the simple words?
yeah,
Don't be
like
hurry or yeah, please.
in physical design, like what you're saying, uh, routing, placement, and like other things, static timing analysis.
Hmm.
These sub modules are like it will be like a main thing in domain itself. Like it's
In physical design only. Yeah.
yeah.
That's a good question. Yeah, I'm going to answer this thing. The thing is like we can see routing in many domains also. Inside this VLSI only, analog layout one stream is there. Okay. Those people will use routing. The concept is same. Okay. But where we are really using that before entering into this clock tree synthesis or after this CTS stage, where we are going to use. I mean, what I'm trying to tell is like this floor plan, power plan, CTS, routing. These are the steps in physical design. Okay.
Yeah.
In design verification, taking the RTL code, converting into gates, and deliver a gate level net list and check the timing. That's their perspective, but they are using static timing analysis. You got the thing, right?
Yeah.
Based on our requirement, we arranged all these macros. Sorry, I forgot the name. Good name, please. Kiran, yeah. So in the floor plan, Kiran, we arranged the macros. Okay. In the placement, we're going to make all these cells sitting inside this core area. 2 stages got completed, right? So here we will check the static timing analysis. Okay. So why? Because macros to the standard cells, if the distance is very far, then obviously the timing would be very high, right?
Yes.
So that's how. Based on the stage, we use static timing analysis. I'm not claiming like static timing analysis is only our syllabus. Nowhere you will see static timing analysis part. I'm not telling that. Okay. Based on the stage, based on the stream you are inside. Okay. You are going to use. This is like sanity check, Kiran. Okay. So how far the macro and the stand cell is sitting. So you are going to check the timing. If these two are having communication, how much time is being taken? This is the sanity check. So this STA will be performed in synthesis also, and these kind of stuff will be performed in RTL stages also. Okay. So that's a different concept. The sanity check is same. The concept is same. How they are using, what tool they are using is being different. Understood the thing, right?
Yeah. Yeah, I came this doubt because like when I see like some openings were there for STA, floor planning engineer, like on layout engineer. So that's why.
Understood. Actually, lots of streams are there, but at what stage? I mean, STA inside synthesis you can perform. Inside PNR you can perform. Okay, but a dedicated STA people will be there. Okay. If you are doing physical design, you need to perform STA also. Okay, but dedicated STA people is different when compared to the physical design people who knows the STA. Why? Because 1 second, I will try to tell you in a good example where this is annotated. Fine. Yeah, for example, so just take India map. Okay, Kiran, take India map. Okay, one of the each state is like one block. Okay, like Karnataka is one block. Just imagine. Okay, Maharashtra is one block. All these are like blocks. Okay, just imagine. Okay, these your state timing will be controlled by you. Okay. Dedicated STA people are there, right? These people will control all over the India's timing. Understood the thing, right? All over the blocks timing, they're going to control. Inside your block, you need to have knowledge of this STA. You need to close your block timing only, your block. Okay.
It's like CM and the prime ministers.
Yeah. Perfect example.
Yeah.
That's what I'm trying to tell. Understood the thing, right?
Yeah. I came to know. Got the point.
Yeah, fine. Good, man. Yeah. Anything else? Anything. Some people are getting answers from others' questions also. It's fine, but it's time to open your mouth actually. Ask your questions, please.
Hi, sir. I am Sriranjan.
Sri Ranjani. Ranjani?
Yes.
Yeah, please. Sri Ranjani, tell me.
In the period of training, whether
Mhm.
any tests will be conducted, like assignments, tests.
Yeah. I mean, we're going to conduct mock interviews, as I said, and we're going to conduct assignments also. Okay. I mean, whenever we are tracking our performance, then only we can get our confidence levels. Okay. Based on the assignment rating, right? You will come to know, oh, this is how only I understood the concept. I need to rebrush the thing. Or you will come to me like, please explain this thing so that I can get much understanding about this concept. When will you get all these things? Whenever you face an assignment. Okay. But don't worry, this is not like you got the less marks, you call your parents. This is not the kind of stuff. Okay. This is like a self-assessment. You need to assess yourself. How much I'm really getting into this? How much I'm really getting understanding this? Okay. Your
Okay.
self-assessment. You need to judge yourself. How really I'm good in this? If you really have any doubt, you just please come to me and get the things done. Get your doubts cleared. Okay. No need to worry. And yeah, no need to worry about anything related to PD. I'm here to teach you. And if you are inside this upgrade VLSI technology, I can tell you in a single sentence, you are in safe hands. From scratch, you are going to be a pro. That's what I can tell you in a single sentence. Okay.
Yeah, okay.
Yeah.
Thank you.
Anything else? Anybody else, please? Yeah. That's all from my side. If you have any doubts, please unmute your mic. And if not, let's wind up the session. Anybody? Last call. Fine. That's all from my side. If you have any issues or any questions, I'm showing the number, right? Please call to this number or reach out to the HR, or this is the mail ID. Okay. Contact us and get your seat registered as soon as possible. I'm trying to tell you again and again. Nowadays, openings are very high. This is the time enter into this VLSA industry. Okay. Don't waste your time by choosing all these things. Which institute is cheap? Which institute is giving that stuff, this stuff? Don't wait for all those things. First, I mean, as I said, from my side, this is what we are going to offer you. From when we compare to our competitors, we're going to teach you these things as a plus. Okay, that's what I'm trying to tell you. Just enter into this VLS industry as soon as possible. Right now, we have many openings. One day you get wasted. One day you are away of your job. Okay, that's what I'm trying to tell you. Yeah, that's all from my side. Thanks for your time. Thank you.
Thank you.